All right, let's dive right into this explainer. Today we're doing a high-stakes, interactive technical audit to figure out if your enterprise AI deployment is genuinely production-ready. We're skipping the theoretical stuff today and using our source material as a hardcore professional audit checklist. So if you're deploying large language models into production right now, consider this the reality check you've been waiting for.
Seriously, take a look at your current setup right now and ask yourself, is your LLM pipeline actually legally defensible? Because the operational threat surface out there has evolved dramatically. We aren't just talking about users typing ignore previous instructions anymore. We're dealing with layered, context-aware prompt injections hiding inside seemingly normal documents. A catastrophic data leak or a massive regulatory fine could literally be just one complex prompt injection away if your systems aren't built to fail safely.
Think of this agenda as our professional audit clipboard. We are going to systematically walk through 5 key areas: the architecture audit, the guardrail stack audit, the adversarial defense audit, the evaluation audit, and finally, the compliance audit. Let's get to it.
Starting with Section 1, the architecture audit, where we'll be dismantling the passive wrapper. We have to start with your baseline architecture, because what passed for an acceptable API wrapper back in 2022 is honestly a massive operational liability today.
The biggest, most crucial shift we're seeing here is the move to a dual-track architecture. In a naive 2022 setup, user input went to the model and the response bounced straight back to the user, maybe tripping a basic profanity filter along the way. But in a modern dual-track system, no way. The model's response never goes directly to the user. Instead, it hits a raw output buffer. It sits there in a transient state for rigorous asynchronous validation. If it fails a check, it gets rejected, rewritten, or flagged. You have to treat every single inference request as a potential security event.
Moving on to Section 2, the guardrail stack audit. Let's break down the exact technical steps you need to configure a multi-layer defense system.
Because a single filter just doesn't cut it anymore. A proper stack intercepts inputs across multiple distinct layers. It starts right at layer 0. Aggressively masking healthcare or financial PII and catching hidden JSON fields. Then it stops prompt injections in layer 1 using classifiers and structural analysis. Next up is layer 2, where it validates factual consistency and toxicity. And finally, it routes automatic remediations in layer 3, deciding instantly whether to retry a prompt, block it entirely, or escalate to a human. This is where your governance policy stops being a document and becomes actual operational code.
Now, here's where engineers often trip up. Adding safety checks without tracking cumulative latency. You have to strictly manage your latency budget. Say your total P95 latency target is 1500 milliseconds, meaning 95% of all requests must be processed faster than that. You have to allocate every millisecond carefully. Inference eats up 800 milliseconds, layer 0 PII scrubbing takes 30, layer 1 injection detection gets 15, leaving you 655 milliseconds for your complex output validation. By using small, dedicated GPUs specifically for these guardrails and running these checks in parallel, you can ensure this multi-layer validation doesn't completely destroy your application's real-time speed.
Section 3 is the adversarial defense audit. We're talking red teaming and chaos.
This is all about active defense. You can't just ask, did anything go wrong today? You have to constantly ask, what could go wrong, and can I reproduce it? Automated red teaming essentially replaces slow, manual penetration testing with AI-generated attacks. It uses a dedicated LLM as an attack generator to fuzz your pipeline at scale, throwing different personas and formats at it. Your target system takes the hit, while an evaluation oracle figures out if the attack actually breached your policies. And this oracle isn't using basic rules. It's running advanced policy compliance classifiers and embedding libraries to catch really sophisticated evasions.
And we absolutely have to audit your chaos engineering tests. You deliberately break the system to see exactly how it fails. For example, simulating API timeouts to validate your fallback behavior, or injecting adversarial bursts to see if your system silently degrades and fails open under load, which, by the way, is a massive red flag. You can even trigger verbose errors just to see if you accidentally leak sensitive system prompts or internal tool definitions. The core rule here: systems under stress must fail closed.
That brings us to Section 4, the evaluation audit. We are moving way beyond basic accuracy to catch the silent killer of enterprise AI.
If your checks are still relying purely on traditional accuracy, you are flying completely blind to the true danger in generative AI. Sure, traditional accuracy might say a model is 95% correct, but it completely fails to capture confidence calibration. You will totally miss those terrifying instances where a hallucinating model is dangerously wrong but acts highly confident in its fabricated response.
So what's the fix? You absolutely must test for semantic consistency.
You do this by running reformulations of a prompt at different temperatures. If the model truly knows the fact, those resulting vector embeddings will cluster tightly together. If the answers scatter all over the place, the model is just guessing. On top of that, you have to verify claims by grounding them against a real-time vector knowledge base. No semantic match in your verified data, it gets a low grounding score and gets flagged immediately.
Finally, Section 5, the Operational Governance and Compliance Audit.
If you want to operationalize governance, safety evaluations have to be as friction-free as your standard code testing. Your CI/CD flow needs automated feedback loops with rigid safety gates. Minute 0, a pull request gets blocked flat out if safety metrics drop. Hour 1, the staging gate runs extended red teaming and bias tests. Day 1, the production monitor samples live traffic and triggers automatic rollbacks if performance degrades. Again, say with me, systems under stress must fail closed.
Now, the global regulatory landscape is incredibly fragmented and moving at lightning speed. To future-proof yourself, you need to configure jurisdiction-aware compliance profiles. Do not hard-code rules into your pipeline logic. Instead, use declarative profiles that automatically adjust safety parameters based on context, seamlessly shifting between the EU AI Act, US regulations, or Gulf region cybersecurity frameworks depending on who is using the system.
All of this incredible architecture has to feed directly into a production compliance dashboard, because when regulators come knocking, they are going to demand hard evidence. You need real-time views of toxicity and bypass rates. You need immutable, cryptographically verified, append-only audit trails that track the evaluation chain of every single request. Your automated report generator has to instantly produce undeniable proof of your system's safety logic.
As our source material puts it so perfectly, compliance reporting is increasingly a technical requirement, not just an organizational one. This isn't just a fun policy chat for the legal team anymore. Securing an LLM pipeline is a hardline technical requirement baked directly into your codebase. You can't just write a manual model card once and forget it. It has to be programmatically generated.
So bringing this all back to you, take a hard look at your own inference pipelines operating out there in the wild today. Will your architecture pass this audit? Have you actually dismantled the passive wrapper, set up semantic consistency checks, and built those immutable audit trails? Or are you operating a massive liability, just waiting for a compliance disaster to happen? Think really carefully about those dual-track architectures and latency budgets we covered today, because the threat surface definitely isn't waiting around for your next update. Catch you on the next Explainer.